Hi, welcome to Solving Health Mysteries in Your Family History. This is a talk that was given on June 26, 2021. Unfortunately, the first few minutes of the talk were not recorded. This short introduction will provide that information so that you can fully understand and enjoy Katja's talk. Purpose of the talk was to analyze using modern epidemiological methods, family history problems of a medical nature. And the question we are going to be asking is, was this family tragedy something that was caused by circumstances locally to the family, or was this part of a general trend in Norwegian society? Katja asked people in the genealogy interest group to look in their family history and look for possible medical problems or medical anomalies that they did not fully understand. And several of the members came forward and presented these issues, and Katja has researched it and provides her results using epidemiological methods. Of course, in these case studies, the historical record will not give us definitive answers, but will let us make informed guesses. The first case study dates from 1742, and in a matter of a little more than a couple weeks, 4 children in the family, aged from 9 years old to 5 months, tragically died. The question is, what can we say about these tragic deaths? The epidemiologist will first ask what is known as the PPT, person, place, and time, and gather this information as a starting point towards epidemiological research. At this point, I will turn the talk over to Katja.
To confirm that those were the 4 cases that were reported in the family story. So we had documentation for that. And so as an epidemiologist, after I look at those PPTs for person, place, time, the questions that come to mind are, was there anything unique that was happening in 1742? So was there a famine? Was there a natural disaster, a war, an epidemic? And if it is an epidemic, what were the infectious diseases that were occurring then? So I decided to start my search using Google Scholar, which is something that anybody can access for free. You just type in Google Scholar, and the search bar will look for published academic articles. So this is for things that are, it's not a general search of the internet, it's for things that have been peer-reviewed and published in a journal. So one of the first articles that I found was this article on the decline in mortality in the Norwegian parish Asker and Bærum, circa 1700s into the 1800s. And so this article had a figure that mapped out the death rate over time. And you can see on this figure that there are 3 spikes where there were higher years of mortality. And so those 3 peaks were 1742 to 43, 1772 to 73, and then 1808 to 1809. And the article said the years 1742 and 1773 were serious crisis years for the crude death rate. And crude death rate means just not adjusted for age differences over time. So this is telling me there is something that was going on, that it's not just this one family or that one town that had a crisis in 1742. So this article gave me some sense of what was going on, but it didn't say why the rate was high. This was purely demographics. So it just said the rate is high with no further explanation. So I needed to go back into the record. So I found an article from Norway that was looking at, strangely, the title is Health Buildings in Norway, looking at how hospitals and architecture and those sorts of things had changed over time. And in that article, it said, from the start of the 1700s to about 1850, birth rates were generally high, which is true, so that each family had an average of 4 to 5 children. Until about 1815, the mortality rate was also high, with significant exceptions in some crisis years when it was even higher. So the exceptions were not that it got lower, it was that it got higher. And it added that the most significant diseases in the 1700s were dysentery, typhoid fever, typhus, and smallpox. And since this is a medical historian who's writing, I assumed that those were based in good historical records and that that's where I should start narrowing my search to try to understand what was going on. So these 4 diseases, just in brief summary here, dysentery is a bacterial infection that causes bloody diarrhea, and it can cause intestinal wounds that perforate. So there were outbreaks of dysentery. They still happen in some parts of the world today. Typhoid fever is a food and waterborne bacterial infection that causes an unrelenting high fever and severe diarrhea, although typically it's not dysentery, it's not bloody diarrhea. So to those of us who work at epidemiology, we talk a lot about body outputs and their types. So these are meaningful differences to us. Typhus is a bacterial infection transmitted by body lice that causes high fever, headaches, a rash, diarrhea, possible internal bleeding, and other symptoms. And then the 4th one is completely different because it is not a diarrheal disease, smallpox, which was a viral infection that caused a high fever for several days, followed by a rash that spread over the whole body. The incidence of smallpox decreased in Norway after a vaccination was developed by Edward Jenner in 1796. So this was still happening as epidemics in most of the 1700s. If you look in your family records, you may see that churches in a lot of places kept track of vaccination records during the 1800s, and that was typically for smallpox vaccination, that the churches were registering births and deaths, baptisms, christenings, and vaccination. Those were all parts of those registries. So the problem with just looking at these 4 is that 3 are very hard to differentiate, even with laboratory tests that we have today. So these were happening in the 1700s pre-germ theory. And this is very imprecise reporting. So I'm not exactly sure how to interpret how these would have been recorded in the past. And if it was recorded as typhoid, is it actually the bacterium that causes typhoid, or was it just sort of a set of symptoms? But this is a good starting point. The next thing I looked at was the case fatality rate, which is the percentage of people who get a disease who die from it. With antibiotics, most bacterial infections have very low case fatality rates. But before we had antibiotics, which didn't happen until mid-1900s, the case fatality rate for dysentery was about 5%. For typhoid fever, it was about 10%. For typhus, it was as high as 60%. And smallpox was about 30%, but it could be higher, it could be lower, depending on the strain. When we see 4 children in one family die, the temptation is just to say it has to be the thing with the highest case fatality rate, because how else could we explain a family having that kind of bad luck? The challenge here is that our understanding of case fatality rates doesn't do a good job of accounting for people who are severely malnourished. And so that combination of being vitamin A deficient, calorie deficient, having other vitamin and mineral deficiencies, we have to adjust in our thinking for the vulnerability that comes with that if there's a famine or a severe hunger happening at the same time. So the actual case fatality rate during an epidemic could be much lower in a well-nourished population and much, much higher in an undernourished one. I couldn't find any article in English or Norwegian languages or several others that I tried about those 4 diseases that were specific to Norway in 1742. But I did find a very recently published article that looked at Sweden. And so we have to ask, is a Swedish study relevant? And part of the answer here is that the borders have been fuzzy So Sweden was Norway, or Norway was Sweden, or Denmark at various points in time. So we can map out where this article from Sweden was happening, but it's fairly close to Norway. So we can assume that these were experiencing similar sorts of trade patterns, similar waves of epidemics, both Norway and this part of Sweden. So looking at that, the Sweden study shows a big outbreak in 1742, just like we had seen looking at the study from Norway. And so that first peak is from 1742, and that second peak is from 1772. So those three peaks that you see in the graph at the top right match the three peaks in mortality that we saw in the Norway demographic study. So that gives me some sense that I can assume that this has relevance. So the outbreak that was happening in Norway also seems to be happening in Sweden. The graph at the top and the bottom, so the top is the Norway article, the bottom is the Sweden one, and we have more years for Sweden, and we see that these outbreaks happen, once a generation or so. The article from Sweden then goes through a set of different possible diseases that they were hypothesizing could be going on. So there were some cases of smallpox that were happening. That's the red below. So the black line is all deaths, and the red is the deaths that were recorded as being due to smallpox. So yes, there were some smallpox cases, but that is not causing the spike. And then we can look here, there were some cases of fevers. Okay, not a terribly helpful descriptor. The assumption is that that would be a fever like typhus. So some cases of that, but not a big outbreak. And then it has the deaths from dysentery. And we see that there's this huge spike from dysentery in Sweden. And so I think it's very reasonable to assume that that was also the spike that we were seeing happen in Norway. That just is such an unusually tall number of cases. Looking historically, we do see that every 50 years or so, we see a big outbreak like this. And part of what we see with outbreaks is often after a big outbreak, there are no cases for quite some time because every single person got infected, they got immunity from that infection. So they're not vulnerable to getting it again. But then as new people are born, the susceptible population grows, and then there's another outbreak. So based on the articles that I was able to find, if we go back to our summary that all 4 children in one family died in September and October 1742, we now know that there was a bad break of a dysentery causing disease in Norway in 1742. So it seems like it's a reasonable assumption that that is what affected this family, that it was a diarrheal disease outbreak. Dysentery usually has a lower case fatality rate than typhoid. Typhoid can cause intestinal perforations and bloody diarrhea. So we can't be specific about what the exact pathogen is, but it was what was understood to be dysentery at the time. So I think with reasonable certainty, we can see what happened with that family. Our second case study, as we get a little closer to the current time, is from 1863. And the case study that I got from one of our lodge members is on this page, you will find 2 of my relatives listed as dying just weeks apart. The first is 9.5-month-old Johannes, who died October 15 of 1863. The other is his father, Christian, who died October 30. Then his wife, who would have been Johannes's mother, died a year later in October 1864. I don't see any notation for cause of death around their names, but it always seems strange to me that my great-grandfather lost both parents and both siblings before he was 5 years old. And so we can see the parish register there that starts to tell what's going on with this family. So looking at those PPTs, that person, place, time again, we have death records from this family. So Johannes, October 15, 1863. He has a brother who's younger than 5 years old named Gustav, who also died somewhere that season. And the father died within 2 weeks of Johannes. A year later, the mother dies, and also his grandfather, his maternal grandpa, had died in March of 1863. So when I look at this, like with the previous case study, I want to know, is there anything unique about 1863? So a famine, natural disaster, war, epidemic, what diseases might have been occurring? It's a little trickier though for this case study because this is spread out over a year and a half. So we have a father and son dying within 2 weeks, but the mother a year later, the grandpa half a year earlier, may have nothing to do with it because it's not quite so tightly compact in time. So my initial impressions are that, first of all, infant mortality occurred a lot. So an infant not surviving would not have been an unusual event. The death of the brother, who was less than 5 years old, I wasn't able to find a date for that, so we don't have a lot of information. Children less than 5 years old dying at this time, also not that unusual. It is somewhat unusual that the father would have died. He would not have been an old man, and for the father to die in close proximity to the son starts to point toward an infection. The mother dying a year later at the same time of year maybe raises a question about whether there's some sort of infection that causes epidemics around harvest time. The challenge there would be that typically we see, when it's not something like the dysentery that we just saw or smallpox, harvest time at the end of the summer is when most people were at their most well-nourished, because they're able to eat berries and fish during the summer. If they're farmers, they're just bringing in a crop. So this would be the time of year when they would typically be least susceptible unless there's a famine going on. And the grandfather dying in March of 1863, March is a time where hunger would be at its highest level. So it could be that this family was chronically malnourished, but there's just a lot of uncertainty. So I wasn't able to find a whole lot about this year in particular, but the first thing that caught my mind was a paper of rural infant mortality in the 1800s. And this is a map of infant mortality, so deaths before the first birthday for the late 1850s. And the red up that we see at the very north of Norway, that's where about 20% of babies did not survive to their first birthday. Down toward the south, we see some places where it's more like a 10% mortality rate. But the case location that's in a green, which is like the lowest mortality rate, that's still about a 10% infant mortality rate. So in the healthiest places, about 1 in 10 babies did not live to age 1. And the approximate ratio of deaths before age 1 and then between ages 1 and 4. So cumulatively around the world today, even in low-income countries and in every country a century or more ago, the death rate for kids under 5 is substantial. About half of those deaths happen at least before age 1, and then the rest after that. So if 20% of infants weren't surviving, it could be that up to 40% of kids didn't reach their 5th birthdays. So again, the idea of 2 young children dying in one family in today's way of looking is something we cannot understand in the high income country perspective. But back then, that may not have been that unusual in the community where this case location happened. So the late 1850s, according to this article, were a period with relatively good harvests, a stable climate, and few epidemics. So stable climate meaning they weren't reporting really, really bad, like icy winters, flooding, locusts, or whatever kinds of pestilence could have passed through, that it was a fairly stable weather system time. But then it added, in the early 1860s, harder times struck, and harvest problems were reported by several administrative reports from the provinces due to bad weather. The epidemic climate also worsened with several waves of children's diseases, especially measles. So this case study is from 1863. And even though the case was in a relatively low, maybe 10% infant mortality in the late 1850s, this is an area that was heavily affected by that bad weather that created the malnutrition. And that would have made kids more vulnerable to measles. So many of you on this call may have had measles when you were children. It is a children's disease. The complications are most common among the youngest children, especially infants, but anyone less than 5 years old. It is most severe when kids are undernourished, especially if they have vitamin A deficiency. And the case fatality rate can be as high as 25% when it is affecting an undernourished population. If the case fatality rate is 25% in vitamin A deficient kids today, when we have medical treatment, so we don't have an antiviral, we can't cure measles, but we can do supportive therapy. So if they're getting dehydrated, they can have IV fluids. That there are things, Tylenol to reduce fevers. There are things that we can still do to help. So it would have been even higher back when these cases were occurring. So the best guess, and there's no way to prove this, but given what we're seeing in the historic records about malnutrition and measles epidemics in the 1863 time period, it's reasonable to assume that this family was just extremely undernourished and that both brothers could have died from measles. And the parents would not have died of measles. They would have had measles as children, so they wouldn't have been dying of that as adults, but they may have just been dying of tuberculosis, which is exacerbated by undernutrition, pneumonia, diarrheal diseases, any of those things that people who are undernourished are more vulnerable to getting, and when they get them, they're less likely to survive. So unfortunately, in this situation, we don't have certainty, but it looks like they were a chronically undernourished family, at least during those years in the early to mid 1860s. Our next case study is from 1867 to 1868, and the person who submitted this case study added in some family photos of these two sisters, Avina and Sigrid, and the sisters both lost babies in the same month. So this was a family that split its time between living in the capital city and living in a farming town that's about 70 miles north of Oslo. In May 1867, Sigrid gives birth to a daughter named Agnes. In October 1867, Avina has an 8-year-old son named Jakob Emil, who dies at age 8. As is often the case, that family reused the name. And so there is a second Jakob Emil who's born in August 1868, less than a year after the first Jakob Emil had died. Agnes dies at 13 months of age in June 1868. Just a few weeks later, the second Jakob Emil dies when he's 13 days old. And both of those deaths of those babies occurred on the farm that's north of the city. So when we look at the case study here, if this will advance, the premise here for the person, place, time is there are 3 deaths that we're interested in. Jakob Emil dying at age 8, his cousin dying age 13 months the next year, and his brother dying as a newborn shortly thereafter. When we look at the records from Oslo, these are beautiful in terms of handwriting, right? This is a register that is complete and it is easy to read. It's well done calligraphy, straight lines, and that column down the middle is listing the cause of death for every single person in the register. So it's remarkably complete. And based on what is in the register here of Jørne Waterfoss, that would translate as cerebral palsy. And again, we have to think back to what would that have meant in the time. We can't be too sure. This could have been something that was a condition that was present from birth. It could have been something like hydrocephalus that may have been related to some sort of infection. But it looks to me like this could have been something that was a chronic condition for this boy who was not able to survive it for some reason that we don't know, probably that they didn't have modern medical care. When we look down that page, this is not related to the family story, but I just thought you might enjoy, since if you were looking for your own family tree, seeing various causes of death, we've got several people on that same page in the register who are dying of lungeterring, which is pulmonary tuberculosis. We've got syphilis, tubercular meningitis, diphtheria, and 2 children that are listed of dying of scarlatina, which is scarlet fever. And so if you want to see causes of death, go to Digital Archiva and look at the Oslo City Church Register, because you can see sort of the diversity of what things are because it's such a complete record. I looked up publications of health records. This is an article from 1872 that I found using Google Scholar that is looking at the official report of health of Norway in 1868. So this says that among the deaths for which causes were assigned, and there were lots for which causes were not assigned, the most common causes were pneumonia, cholera and diarrhea, measles, scarlatina, so that's that scarlet fever, bronchitis, apoplexy, I don't even know how to pronounce that because I do not live in the 1700s, and leprosy. And leprosy may have been Hansen's disease as we understand it today. It could have been things that cause skin disorders, unspecified. And then it adds then that consumption, which is an old-fashioned name for pulmonary tuberculosis, heads the list, and typhus fever stands third. So I don't know why they did this out of order, but the actual order is pulmonary tuberculosis, pneumonia, typhus, cholera and diarrhea, measles, scarlet fever. So that's a lot of infections. We just don't see registers like that in the US or Norway with any of those listed in the top 10. And there's just lots of infection in the pre-antibiotic era. So both Agnes and the second Jakob Emmel, because they died in the farm area north of the city instead of dying in the city, they are listed in the church register in that rural area. And just looking at this, you can see that this does not look like the previous page. The handwriting is not as precise, it's crooked, it's incomplete. We have basically nothing listed about causes of death. And so this, just for those of you who are looking through your family trees, it's kind of luck of the draw, whether your ancestors happen to live in a place with meticulous record keeping, or they happen to live in a place that did not have such extensive attention to record keeping. What's interesting then from this, a couple of things. First of all, we can see that, okay, let me move I'm blocking my own cursor with my pictures here. So this is the register for the city. And Jakob Emmel, the second one, is also listed in the Oslo City Register. So let me just show that again. This is the record, my previous slide, of dying in the rural area. And then when we flip here to the city, we see that the next to last line for the year in which he died, he's listed here as well. And so what we think happened there is the family had said that there was a seminarian in the family who worked in the city, and these sisters are splitting their time between the city and the rural area. The baby dies in the rural area and is recorded, but the family lives in the city most of the year and wanted the name to be properly recorded in their home parish. And so the death of this baby is registered twice. In this register in the city, the cause of death is that it's listed as being born too early. And so this was a premature birth, probably a very tiny baby who was not able to survive. If we do that side-by-side comparison here, again, of the city and the country, the precision and the listing of causes of death is same register, same columns, very different levels of detail. And the conclusion here was just that we aren't going to find more details, but it's amazing to have the same person listed in two places. Our last case study here is from the 1870s to 1880s. And the story here is my great-grandfather had 14 or 15 children. I think that his first two wives died in childbirth, and many of the children died very young. There may or may not be any patterns, but it certainly shows the difficulties in that time in the late 19th century. They seem to either die very young or live to a very ripe old age. So the person, place, time here, again, we've got a man who has two wives who die within 5 years, one wife at age 23, one at age 25, and at least 5 of the 15-ish, more or less, children did not survive infancy or early childhood. So the first wife is Sella. She has a daughter in 1862. Sella dies a year later with what appears to be a childbirth complication. And sadly, it looks like the daughter 20 years later also dies in childbirth. It was very risky to be pregnant and delivering a baby back in the 1800s and before. The second wife is Maria. She has a child in 1865 who dies when he's 10 years old. A second child died shortly after birth in 1867, and then she died a few weeks later, probably of pregnancy complications. The third wife is Margreta, who has 12 children. 8 of them survive childhood. So those are all things that are in the family records. The infant mortality rate in this family is not that unusual for the time. In particular, noting that this case location is in a place that had very high infant mortality rates back in the late 1850s compared to Norway as a whole. So that is not a surprise that the family is seeing in the records. It is interesting to look at the registry page for Sella here. Sella's death is listed in the blue box, and that purple box that I put down the first column on the right-hand page lists causes of death. Very few entries there. It's mostly blank. There are several places where it lists maternal fever as the cause of death. And I suspect that the reason that's listed, but it's not saying pulmonary tuberculosis, cholera, is that people knew when a woman was pregnant and had a labor complication and died, or when there was a newborn who died. Like, that's an easy thing to diagnose, relatively speaking. So they would have had some more certainty about that to list. The language here at the bottom of that purple box is about Sella, and it says that she died in the maternity bed 3 days after the birth. So it looks like there was some sort of complication where she may have had hemorrhaging or something that caused her over several days to get weaker until she wasn't able to survive. Interestingly, the only other listing on this page is right below hers, and that person died of a sore throat, of a throat disease. And I don't quite know how to interpret that, but that must have been something that was obvious enough to people that they felt confident that was the cause of death and recorded that. So Sella, who was the first wife, is a confirmed case of maternal mortality because that's listed in the register. But the register doesn't list the cause of death for the second wife. And we can see here in the church register that Marie died at age 25. That's what the two pink circles there are. She's 25 years old. And then John died at 1 day old. And they are listed together, but they didn't die on the same day. If we zoom in on that, you'll see that John, who is listed second, actually died first. He died on May 17 and was buried on May 28. and Marie died second on June 9, and she was buried on June 15. So that does raise a bit of a question about whether this is a case of maternal mortality. And the answer from a health science perspective is that even today, we say that deaths up to 6 weeks after delivery that are related in some way to the pregnancy are considered to be pregnancy-related deaths.